Okay, today we're doing a half lesson. We're doing more with volumes of pyramids, which is kind of a carryover from lesson 12. And let's quickly review what those requirements are for finding the volume there. So to find the volume of each shape, be sure to include units in your answer if they're provided. Remember, units of volume are always cubed units, and we show that with a 3 up there above our answer. Um, Now to show your work, write what you are putting in the calculator. So show what you're calculating, please. And as a reminder, for finding the volume of these pyramids, and remember that's different than finding the volume of a prism, but to find the volume of a pyramid, we find the area of the base. Let's see here, see if I can fit it. Area of the base times the height, and then if it's a pyramid, we divide it all by 3. If it's a prism, we don't have to do anything else. We don't need this divided by 3 part. That's only for pyramids that extend up to one top point. Now, the area of a base could be any number of different shapes. Most of what we're going to be dealing with is going to have a triangle as the base or a rectangle as the base. And remember, to find the area of a triangle, we take the base of the triangle times the height of the triangle, and then take half of that or divide it by 2. And then the area of a rectangle is the length times the width. Okay, so let's look at a couple examples here. This is the first two that appear on your handout. And for this first one here, it's always good to name the shape before we get started because naming that shape is going to tell us the shape of that base. So this is definitely a pyramid, meeting at that one point at the top. We have triangular sides, which we said is the definition of a pyramid. And then we look at our base. This is resting on its base the way that it's shown, and the base is a rectangle. So we have a rectangular pyramid. We need to find the area of this base first. So I'm going to outline the base here. That'll help as we look for the length and the width, because remember the area of a rectangle is the length times the width. Length times width. It doesn't matter which one we call the length or the width here, but we have 10 and 8 along our base of the figure here. So we're going to multiply that to get the area of the base. So the area of the base is 80. And then we multiply by the height of the pyramid. Remember, the height of the pyramid has to be perpendicular to the base. That's this little right angle corner here. It's showing that this height is perpendicular to the base of the figure. We're not looking at a length along this slanted side because that would not be the height of the figure. So our height here is 6 inches. So we're going to multiply the area of the base, 80, times the height of the figure, 6 inches. And then we need to take this entire, this would really be the volume, the full volume, but it would be of a rectangular prism going up to another similar rectangle here on the top instead of a point. Because we're dealing with something that's leading to a point, we're dealing with a pyramid, we're going to divide the whole thing by 3. So once we find that total volume, divide it by 3 because it's a pyramid, then what you get is a volume of 160. And remember, I said in directions to make sure to give your answer with a unit of measurement. We're dealing in inches here, and because we're talking volume, we're talking about cubic inches. That's inch by inch by inch. We have 3 dimensions that we're looking at here when we calculate volume: length, width, and height. All right, the same process would be applied here to this next figure. The difference is we have a different shape. So it's still a pyramid, but if you look closely, and this copied a little dark, our base is actually right here. It's a three-sided base, a triangular base. So this is a triangular pyramid. That means when we find the area of the base, we need to take the base and height of the triangle and divide it by 2, or take half of it. So that would give us the area of our triangular base, and then we would follow the same process that we did here. Once we have the area of that base, we're going to multiply by the height. Because it's a pyramid, we'll divide that product by 3, and we should have the volume of this triangular pyramid. Okay, going on to the rest of these, I do want you to try these on your own. Couple things I wanted to point out is pay close attention to what that base is. We still have some with rectangular bases, others with triangular bases. Remember, either shape, we still have to find the area of it. And then we have some more unusual shapes down here that we're still calculating the volume of. The important thing here, though, is it does tell us in each of these cases what the area of the base is without us having to calculate it. Okay, so it tells us the area of this trapezoid is 25 square centimeters. The area of this hexagon is 25 square centimeters. So now we just have to worry about the volume. We need to multiply by the height. And these are not pyramids. We wouldn't divide our total volume by 3 in either of these cases because they're prisms. So we're just going to multiply by the height and we'll have our total volume. Now, going on to the back of the sheet, there's a little more problem solving involved with the back side of this handout today, a little more challenging. So it's applying what you've been learning to kind of work backwards. The title of the sheet is Working Backwards. So it tells us in the first one, what are the dimensions of a cube with a volume of 125 square millimeters? Okay, so we have a lot of clues in this question that we need to apply to find what's missing. So the dimensions would be length, width, and height of a cube with a volume of 125. Actually, that should be, if it's volume, it should be cubic millimeters. That should be a 3 there. So let's apply what we know here. We don't have any picture of the image, but we know it's a cube. And a cube is basically a 3-dimensional square where this is a square. That means that our length and width of that square are going to be the same measurement. So we have our length, we have our, well, this would be what we normally call our height, and our width, but we're dealing in squares the entire time. So finding the volume of this by multiplying these 3 dimensions, these 3 amounts are all going to be the same. So my length times my width times my height, which are all the same number, must equal a volume of 125. Being that this is the same 3 numbers, there is a way to calculate this, but not a common way for us to use yet. So I would say this would be a case of just trying a number and seeing what will get us to 125. If you take 2 times 2 times 2, would that be 125? If not, adjust and get to that correct answer. Just remember, all 3 of these measurements are going to be the same because all 3 measurements or dimensions of a cube are the same. For the next one, and this is a lot like what you're going to do with the remaining questions, just with a different shape. It's going to tell you the volume, just like it did here with the cube. It'll tell you the volume of the shape and ask for some other bit of information. In this case, what is the height of the shape? And you can see here in the diagram, our height of this pyramid is always perpendicular to the base. So our base in this case is a hexagon, and it tells us the area of that base is 70 square feet. So our hexagon here has an area of 70 square feet. We're trying to determine what that height is. So we need to go back to our formula for finding the volume of in this case, it's a hexagonal pyramid. Okay, it doesn't really matter the shape of the base. We already have the area of the base. So to find the volume of a pyramid, just in basic terms, not worrying about the shape of the base here again, we would take the area of base times the height, and this was talked about in the first page or the first page of our video. And then because it's a pyramid, we're going to divide all of that by 3. All right, that is enough information to create an equation that we can solve. So we'll fill in from this information above into this equation what we know. All right, we know the volume. We're told the volume is 210 cubic feet. So 210 is the amount of my equation. The area of the base is something we were told as well. That was 70. The height is the thing that we're trying to determine. That's going to be my unknown or my variable, h. And it's, of course, still going to be divided by 3 because it's a pyramid. So working this backwards now, let me show you what I would do. To solve this, I'm running a little short on room, but right now, my variable and the coefficient are being divided by 3. I want to cancel that. So I'm going to multiply by 3 to counteract. So we'll multiply this side times 3 and balance it over here. All right, now I have, let's see, that would be 600. Let me use my different color here. 630 equals, we canceled this now, so 70h. I just have a one-step equation to solve now. I need to cancel this times 70. We'll divide by 70. And what you get is that h being the height, equals 9 for this hexagonal pyramid. All right, now you've got several more to try. It all kind of falls under the same practice that I just showed you here. We're just dealing with different shapes, different pieces of information, but we're just finding that one missing piece. You're going to use a lot of equations to do this. So set up that equation. That equation that we used here was finding the volume of a pyramid. If you're dealing with prisms, that's not going to be the same equation or the same formula. So make sure you adjust for that, please. If you have any questions, I'm happy to help. I'll be on Zoom. You don't have extra practice problems that go along with these half lessons. So use this time to get your iReady done or to finish up a missing practice problem from earlier in the week. Everybody have a great day.